Welcome to the beginning of lecture material for section 2 of this class. So moving forward, everything will be on exam 2 or exam 3 when we get there. As researchers, we deal with issues of sampling every day. As you will see during this video and during our class time together, a good sample is important for being able to draw any conclusions. Sampling incorrectly or not being totally honest about your sample could result in falsified information and fake news, really. On the other hand, we do sampling, and we as researchers like sampling because it is much more convenient and cost effective than talking to everyone. So I'm going to be skipping through some things, so close your eyes if you get seasick. Go through some examples in class. Spoilers. All right, so let's introduce a few key terms about sampling. A population is the group of people you are interested in studying. It's all potential participants. A sample is the subset of the population that you are able to get in your study. So a population contains the people you are interested in studying, and the sample contains the people that you actually collect data on. So a population, as you can see here, is everybody, and a sample is just a tiny, or I mean, it can be as big as you want, but most likely it's going to be a smaller subset of people that you actually talk to. So representativeness is the ability of a selected sample to speak for people or groups of people in the population of interest. In other words, representativeness is the degree to which the answers of your sample would represent the opinions of the people in your sample, in your population and sample. Generalizability is how much you can apply your findings to people or groups of people. So the questions we ask here are, does your sample represent your population, and are the results of your sample generalizable to your population? So if I talk about, okay, in my sample, I found that Latter-day Saints have better marital quality. I need to ask myself, is my sample good enough that I can generalize that to all Latter-day Saints, or do I have to say Latter-day Saints in my sample? And that's especially important when we talk about sampling bias. Sampling bias is when one or more parts of a population are favored for selection over other parts of the population. So here on the left, we see our population, and the different colors may represent different types of people. So you could have a color for race, or colors may represent socioeconomic status, religious affiliation, political stance, whatever. When we look at our sample, so that's our population on the left. Our sample is on the right, and we see that we are missing some groups of people. For example, we don't see any yellow or orange people in our sample at all. So because our sample does not represent the population, it is also not generalizable. This is pretty easy to see when we look here, but sampling bias is one of the biggest things that researchers worry about. It's actually like a huge deal. And we'll share some examples in class of why sampling is a big deal and sampling bias is dangerous. So there are basically two types of sampling, and then within each of these subtypes, there are 5 or 6 methods, but probability and non-probability. A probability sample is one in which the likelihood of any one member of the population being selected is known. I know that sounds confusing. So the probability, the likely of any one member of the population being selected is known, and all members of the population have a chance to be selected. So a non-probability sample is where the likelihood of any one member of the population being selected is not known, and so some individuals may not have a chance at being selected. That likelihood of being selected is known can be kind of abstract, so let's talk a little bit more about it. So in order to have a probability sample, you have to have a sampling frame. And you can randomize which people you choose from your sampling frame. A sampling frame is all of the people in your population that you have some way of contacting. Although we usually talk about a population, if you want to be super accurate, your population is only as big as your sampling frame. For example, if you say that your population is all Latter-day Saints, but you don't have a way of contacting information for all Latter-day Saints, technically your population would only be your ward or your Facebook friends who are Latter-day Saints, those Latter-day Saints that you can get a hold of. One of the biggest problems in statistical research is when our sampling frame doesn't match the population that we wish to study. So we talk about our population, but really we're talking about our sampling frame. So in my example of Latter-day Saints, we would talk about, oh, well, I interviewed everybody in my ward, so that's how Latter-day Saints view it. Well, no, because your ward could be a whole bunch of Latter-day Saints who are in Utah, which may be in a microculture of the West, which may be in the microculture of the United States, which is not Latter-day Saints worldwide. So when we try to talk about Latter-day Saints in South Africa, based on the results we have from Latter-day Saints in my ward in Provo, Utah, then we may not be able to generalize the results of my ward in Provo, Utah, because they don't represent all Latter-day Saints, such as Latter-day Saints in South Africa or New Zealand are not represented in my Provo, Utah ward. Let's give some more examples, and we'll talk more about this in class. So we talked about a Latter-day Saint example. Let's talk about an ethnicity example. In the United States, we have a large range of ethnic diversity. We hope that by randomly choosing, there's that probability goes with random. Just remember that. Probability goes with random. A probability sample has some random element to it. We hope that by randomly choosing from all people in the United States that our sample will contain the right portion of each race. Portion meaning percentage. So these numbers that you're seeing here are close to the racial characteristics in the United States today. We would hope that the percentages stay the same, even though our sample only has 100 people or 1,000 people instead of 328 million. So in my sample, in order to be representative and generalizable, well, I'll say representative, not generalizable. Generalizable is different, but for representative, I would hope that 59% of my sample would be white, because 59% of the population that I'm studying, the United States, is white. I would also want 6% of some other race, 15% Hispanic, 12% Black. So if I looked just at the racial characteristics of my sample compared to the racial characteristics of the population that I want, I would hope that the percentages matched up, even though the numbers, 59% may be 10 in my sample, but it's some number of millions in the population, the percentages are the same. That's what we want in order to reduce our sampling bias. And we hope that by randomly by randomly choosing people from our population, that's the best chance we have at approximating representativeness across the most number of social categories. So randomization goes with probability sample. So there are 5 different ways. I'm going to talk about just one of them, and then we'll discuss the other ones in class. But I just want to give an example of probability sample so that you come prepared knowing how probability samples are connected with random and non-probability samples are not connected with random. So the first one is a simple random sample. So imagine that you had a list of everyone in your population. You would take that list and you would give everybody a number. Anybody that you had on your list would be your sampling frame. And then you would take a random number generator on a computer, or I guess you could do it by hand. There are random digit tables that you can buy or find online, whatever. And you would go through and you would pick. So if your random number was 10, you would find the 10th person on your list. And then if your next random number was 5, you would choose the 5th person. And then if your next random number was your 100th, you would choose the 100th person from your list. So let's look at this. One way to do this would be a phone book. So you would have your phone book And again, this population wouldn't be everyone in the United States. It would be everybody who was registered with a phone book. That would be your sampling frame, is anybody who has an entry in a phone book. You would go through your phone book and you would write out a number next to every single person. Then you would use a random number generator on a computer to pick which entries from the phone book you were going to include in your sample. So now the numbers on the left are the numbers produced from our random number generator. So that first one, the 23,157, you would go through your list, you would find the 23,157th, I don't know how to say that, entry in the phone book, and you would say, you are in my sample. Next, I would grab the 5,545th entry in my phone book and say, you are in my sample. Once you go through, you would call those people and that you randomly chose, because you used random numbers, and invite them to your survey. The biggest advantage of simple random sample is that it is generalizable to the population sampled, meaning the sampling frame, anybody in the phone book or whoever you have contact information for. But this process can be extremely tedious, especially if we wanted to sample our sample to be hundreds or thousands of people. Doing something like this is just not feasible without a really high-powered computer. So there are other ways to do it. If you get seasick, close your eyes, because I'm going to skip through a whole bunch of other slides and get to non-probability sample. We'll talk about all of these during class. We'll use these exact same slides during class. And there are just multiple ways to do a probability sample, but I want to focus on that during class time and just give you an example of it right now. So non-probability sample, think about non-probability sample as there is no randomization. The likelihood of any one member of the population being selected is not known. That's confusing. We'll talk about it more in class. So some individuals may not have a chance at being selected. So if you don't have a sampling frame that's available, so you don't have a phone book that has everyone in your population that you want, you cannot take a random sample for whatever reason, you can be extremely effective, but generalizability is limited. They're more efficient because you can go faster, and they're less costly, but you don't have the generalizability. So the biggest example, the easiest one here is, sorry about that, convenience sample, purposive, snowball, quota. Again, I'm just going to talk about convenience sample, and then we'll talk about the other three in class tomorrow, or on Wednesday, whenever you read this. So a convenience sample is when you get participants that are easily accessible and available. Remember, it's convenient. Some people call it accidental or haphazard, but it's just convenient. Every single one of you is using a convenience sample for your final paper because you're getting the people who are most convenient, which is your Facebook friends. So there's no attempt to randomize. You're not randomly choosing from your Facebook friends. You're just saying, whoever is willing to take this survey, whoever is convenient on my social media posts or social media circles, that's who I'm going to get. There's no randomization. There's no probability associated with people. It's just who you get is who you get. It's less costly. It's easy, but there's extreme limited generalizability to the population. You cannot guarantee that your sample represents the population you want because you have no randomization. So maybe with this picture, maybe it's really easy to get the red people because they have phones. And so I guess if we're talking about your empirical paper, your red people are like your best friends that no matter what you post, they're going to react to it. Then you have like some family members that are like your green and blues, and then your purple are just some other random people. And then there's that one gray person. But let's say you have some random friends from high school or earlier or other places you haven't talked to for years but are still on your social media. Those are your orange and yellow. They're not likely to take your survey. So they're not the convenient sample, so then they won't be represented in your sample, even though they technically are among the population of your Facebook friends. So remember, probability samples have some sort of randomization, and non-probability samples have no randomization. And we'll talk about different methods in class. Good luck on the exam, and I look forward to seeing you on Wednesday.